Okay, chapter 4, exploring algebraic identities. Now let's start with example 1. Here, this example 1 is nothing but a pattern which is existing in square numbers. What he's trying to explain is, if we take any three consecutive numbers, here he's taking the first three consecutive numbers 1, 2 and 3. Square of 1 is 1, square of 2 is 4 and square of 3 is 9. Now he says add the smallest square plus the largest square and then subtract twice the square of the middle number. That is, this is the middle number. Square of the middle number is 4. So what do you get? 10 minus 2 into 4 is 8. So our answer is 2. Similarly, take another set of numbers. Let us take 3, 4 and 5. What is square of 3? He says here, now he's taking the next three consecutive numbers. Squares of these three numbers is 3 is 9, 4 is 16 and 5 is 25. Here we apply the same logic. We are going to say 9 plus 25 and then subtract twice the middle number's square. So we get 9 plus the 25 is 34 minus 2 into 16 is 32. Our answer is 2. Did you see? Here also the answer was 2 and here as well the answer is 2. Now let us move to the next one. Let us take the next example. Here he is taking number 5, 6 and 7. Square of 5 is 25, square of 6 is 36 and square of 7 is 49. So now we take the smallest square plus the largest square and then we subtract twice the middle square. So how much do we get? When you add 25 plus 49, you get 74, and when you multiply 2 into 36, we get 72. Here again our answer is 2. Now did you see the pattern? So he's just trying to tell us in this example, when you take three consecutive squares, you add the first square and the last square and then you subtract twice the middle square, the answer will always be 2. This is what is stated in the first example. Now after this, we are going to see the first identity of algebra, which is a plus b whole square. Now the first identity of algebra, as you all know, you were introduced to this in grade 8, which is the first identity of algebra. First identity. Alright, this is a plus b whole square is equal to a square plus 2ab plus b square. Now to explain this, here is a square drawn. A and b are the two variables which is on the horizontal, and this a and b are on the vertical side of the square. So when you multiply a into a, we get a square. Then if you multiply a into b, you get this ab. Since a is a larger number, we give more space to it, and we are just considering it as a larger number here and b as a smaller number. And when you multiply a into b, we get ab. This is just like how we find area of a square. Normally area of a square, what we do is we multiply side into side. If you take the smaller square here, it is a into a. Similarly, to find areas, we multiply side into side. Here, when you multiply a into b, we get a rectangle. And when you multiply again a into b, this sideways, we get this ab. And when you multiply b into b, we get b square. Okay, so this is one way of understanding a plus b whole square. We can also understand this a plus b whole square as a binomial multiplied by a binomial. We all know the rules how to multiply binomials. It is a into a plus b, and then we take, that is, we are multiplying the first variable a with a into b, and then we take this plus sign here, and then we take b and multiply it again with a plus b. This is binomial multiplied by binomial. We first take the first term of the binomial and multiply with the second binomial, and then we take the second variable of this binomial, and whatever sign is here we have to put that sign. Okay, so now what happens is we are going to multiply and all symbols used here are going to be plus. There is no negative sign. Okay, so this is a square plus ab. Here it is b into a. We can write that as ab, the same. B into a or a into b is the same. And then this is, first we multiplied with a, then we multiplied with b. Here we first multiplied with a and then with b. So for a into a we got a square, a into b we got ab, b into a is ab, and b into b is b square. So our answer for a plus b whole square is a square plus ab becomes 2ab. Because why is this 2ab? Because ab has got no coefficient. When there is no coefficient we take it as 1, and here again there is no coefficient, we take it as 1. Now when you add two variables you add their coefficients, so we write 2ab. So this is the first identity, and you will have to remember this always. Okay, this is our first identity. Now let's start with example 2. Here he says a is minus 2 and b is minus 3. Now let us prove this for this example. Example 2, a plus b whole square. A plus b whole square is equal to a square plus 2ab plus b square. Now on the left hand side we have minus 2 plus minus 3. So this is our left hand side, and on the right hand side we will be substituting in place of a minus 2, and here he says it is square, plus 2 into minus 2 multiplied with minus 3 plus minus 3 whole square. We are just substituting the values minus 2 and minus 3 in place of a and b. Here what is the principle used for adding these two? Here what we do is the simple rule. We will take this as minus 2. When you multiply this minus sign and this plus sign, we have these two signs. Here it is plus here and here it is minus. So when you multiply this plus and this minus, you get minus, and then it is 3. So whole square of this. Here we use multiplication, minus 2 into minus 2. So when you multiply minus 2 into minus 2, it becomes plus 4. Because in multiplication, two same signs get a plus. And when you multiply two different signs, it is minus. And here there is a multiplication of plus, then a minus, and then a minus. So when you multiply plus into minus, it becomes minus, and then minus into minus is plus. So it is plus, and a minus is minus, and then again a minus becomes plus. So the sign is plus here, and you multiply the three numbers. 2 3s are 6, 6 2s are 12. So we have 12 here, and here again minus 3 whole square is minus into minus is plus, and 3 into 3 is 9. So it becomes plus 9. Your answer here is 12 plus 4 is 16. 16 plus 9 is 25. Okay. Here what do you get? Minus 2 and minus 3. When there are same sign, the rule applied is when the two signs are same for addition and subtraction, minus, minus, both are same sign. So you add and you put the same sign. So it becomes, you add these two, which is 5, and you put the same sign 5, minus. So it becomes minus 5 whole square. And when you find the square of a negative number, it is plus 25, equal to 25. So both sides are equal. Okay, so this is the answer for the example 2. Now we can do this with the fractions as well. Here the two fractions are minus 2 by 3 and b is 3 by 4. So we can do this for these fractions as well, and we will get both sides as equal. Now you can follow in the same place. It is already given in the textbook, but we can do this. So here a is given as, can you see this? A is given as minus 2 by 3 and b is given as 3 by 4. Here we are going to prove this for this identity. A plus b whole square is equal to a square plus 2ab plus b square. So now we write minus 2 by 3 plus 3 by 4. We do the whole square of this, and here again in place of a we write minus 2 by 3 whole square plus 2 into minus 2 by 3, and then b is 3 by 4, and then we have 3 by 4 whole square. Now let us do the left hand side and the right hand side for these two numbers. Okay, now before we do the square, we'll have to add these two fractions. Okay, so first of all, when you have to add or subtract two fractions, we will have to make their denominators same. Okay, we have to make the denominators same, and the denominator should be their LCM. Okay, for 3 and 4, the LCM is 3 ones are 3 and we have 4 as it is. We don't have any other factors, so we take the factor as 2. We have factors here are 3 into 2 into 2, so our LCM is 12. Okay, this is a simple thing which we already have learnt in previous classes. Now let us this is our LCM, so we have to make both the denominators as 12. So what do we do? Minus 2 divided by 3 into 4 into 4, and then plus 3 divided by 4 into 3 into 3, because we have to make the denominators same. So we do it in this way. Okay, so let us not keep this working here. We are removing it. Now this is we will be doing this. Now what is the answer here? It is numerator is minus 8 divided by 12 plus 9 divided by 12 whole square. So what do you get? We write 12 here, and here on the numerator it is minus 8 plus 9 whole square. So what do we get here? We get 1, because minus 8 plus 9. What is the rule we apply here? Adding two numbers with a different sign. So one has a plus and one has a minus. So what we do is, when we have two different signs, we add one is plus and one is minus. What we do is we subtract both the numbers because they have two different signs. So we subtract and put the sign of the bigger number. So here it is minus 8 and plus 9. So 8 is a smaller number, 9 is a bigger number. So we signs are different. So we subtract. So answer after subtraction is 1, and we put the sign of the bigger number. So it is plus 1 divided by 12 whole square. So what is the square of 1? It's 1, and square of 12 is 144. Okay. Now the right hand side. Here it is minus 2 square is 4 and 3 square is 9. And here can you see there are three different signs here. There one is plus, one is minus, and this is plus. So plus into minus is minus, and then minus into plus is minus. So here the middle term will have a minus sign. Now what we do is, since there are fractions everywhere, we can just see cross. Here 3 and here 3, we can cut this 3 and 3, and here again this 2 will be divisible in this 4. It will go twice, and again there is a 2 here. We can cut this 2 with this 2. Okay, now let me remove these underlined yes, and then let us so we have cut all the numbers. The number here is nothing is remaining, so it is 1, and the sign is minus. And here what do we get? 3 square and 4 square, so it is 9 and 16. Now how do we add and subtract these numbers? We have to make the denominator same. So what we do is, we will first make this as, this is a whole number. We will write the denominator, because there is no denominator, we'll put the denominator as 1. Now we have to find the LCM of 9 and 16. How do we find LCM of 9 and 16? Let us just see that. 9 and 16. Let us take the smallest factor possible. The smallest factor is 2. So 9 is not divisible by 2. So we write 9 as it is. 16, when you divide 16 by 2, it is 8. Next again we take 2. Again 9, it is not divisible. We take this 8 and divide by 2, we get 4. Then we do again divide by 2. We cannot divide 9 by 2, so we write this way. Now again 2, 9, it is again not possible. Divide 2 by 2, which is 1. Now let us consider this number 9. So the factor for this will be 3. 9 divided by 3 is 3, and then this 1 comes down as it is, and then we have another divide by 3. So the factors, we stop here. When we arrive at 1 as the final number, we stop here. So how do we find LCM? LCM will be multiplying all the factors. Okay, now let us multiply all the factors, which we started. It was 2 into 2 into 2 into 2, and then into 3 into 3. So how much is it? When you multiply 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16, and then this is 9. So it is like 16 into 9 straight away. We are not able to find anything like lesser than the numbers multiplication of these numbers itself. So 16 into 9 is 144. So let us now come down to this. This is LCM, finding LCM. If you want to, like, you can stop and take a screenshot of this. I am going to remove this finding LCM part, because we need space for completing the sum. Okay, so let us remove this part, and then we have to make the denominator same. So what do? We write 4 divided by 9. So we have to multiply by 16 and 16 to make the denominator same. Minus 1 and 1, we multiply by 144. We multiply by 144 into 144, and then plus 9 divided by 16 into 9 into 9. Okay, so what do we get here? 16 into 4. How much is 16 into 4? If you multiply, you will get 64 divided by 144 minus 144 divided by 144 plus it is 9 into 9. How much is 9 into 9? 81, and here it is 144. So we have 144 as our denominator. For adding or subtracting fractions, we write the same denominator, and here the numerator is 64 minus 144 plus 81. Here, when you do the addition, what do? We have to add a 64 and 81. When you add 64 and 81, both the positive numbers we add, it is 145. Okay, and the negative number, I write it as it is, and then the denominator is 144. So 145 minus 144 is 1, and denominator is 144. And here the right hand side and the left hand side are the same. All right, so we finish with this example 2, and now what we do is we are going to move on to example 3. Before that, there is nothing much here. There is only what is the difference between an equation and an identity. It just says identity is the same, it has the same value. An algebraic identity is an equation that is true for all values. Identity has this, it has the values, whatever value you give for the variables, it will hold true for all values. Okay, for example, a and b, if you take a and b as some integers, some numbers, it will be true, this identity will hold, the left hand side and the right hand side will have the same values. Now after this, there is one more thing, think and reflect. Here it says sometimes a plus b whole square is greater than, it is sometimes less than a square plus b square, and sometimes a plus b whole square is greater than a square plus b square. When is this? He's asking you students to think and reflect when this happens. All right, so I will tell you, when both a and b, if both are, if a and b both are positive or both are negative, then you have a plus b whole square is greater than a square plus b square. But if you have one as positive and the other as negative, one is positive and the other is negative, it can be a or b, either one of them is positive or negative, then you will have this condition. Okay, you can try this out. You can take values for a and b, one positive, one negative. So if you do that way, one positive, one negative, then a plus b whole square will be less. But if both are positive, then a plus b whole square, if both are positive or both are negative, then here this one holds when both are positive or both should be negative. All a plus b, both a and b both should be positive or both negative. But it will be this one, a plus b whole square will be less than a square plus b square. When this happens, this will happen when one is positive. If one is positive and the other is negative, when this happens, then what happens is this condition holds. Okay, now let's move on to example 3. Example 3 is very simple. We will just have to expand this identity, and we will be example 3 is very simple. Let us do that. Example 3. Example 3 is 5x plus 2y whole square. You will have to expand it like a plus b whole square, which is equal to a square plus 2ab plus b square. So if you have to expand 5x plus 2y whole square, that will be equal to 5x whole square. In place of a, we take a 5x, and then in place of b, we will be taking 2y plus, let us put this in bracket, 2y whole square. So the answer is, when you do a whole square for 5x, we will have to 5 whole square is 25 and x whole square is x square. Here it is 2 into 5, which is 10. 10 into 2 is 20. 20, and then you will have to multiply the variables. Now x into y is xy, so 20xy. Let us remove these lines. I don't want any confusion. So we will, this is 20xy plus 2 square is 4 and y square is y square. So this is all. He's just wanting us to write this in the expanded form. So now next one is example 4. We have to calculate 43 whole square using this identity, using first identity. So now example 4. Example 4 is a very simple question. Here he says calculate 43 square using this first identity. So let us keep writing it again and again so that it becomes very easy to remember. A square plus 2ab plus b square. Please memorize this forever. Okay, so 43. So we write this as 40 plus 3 whole square, which is 40 square plus 2 into a is 40, b is 3, and then 3 square. So 40 square is 16 and then 2 zeros. This is how we do a square. When you have a lot of zeros in the number, we add the zeros. Okay, we just find the square of 4 and then here it is 2 zeros should be added next to it. Okay, and here it is 2 into 4 into 3. 2 4s are 8. 8 3s are 24. 24, so it becomes 240 plus 9. So when you add all the three numbers, when you add them, it is 1600 plus 240 plus 9. When you add all the three numbers, you have 9. This is 9, this is 4, this is 8 and 1. So our answer is 1849. Okay, so he wanted us to do this. So that is the end of our examples.